to solve another Leetcode problem. 2963, count the number of good partitions. So let's first try to understand the problem. So we are giving a zero-indexed array nums consisting of positive integers. So a partition of an array into one or more contiguous subarrays is called good if no two subarrays contain the same number. So let's just try to understand this description. So this means, for example, if we have some numbers, let's just try to use another color, maybe. So if we have a number like 1, 2, 1, we can make the partitions like 1 to 1. So it's going to be a 1 partition. So can we make it like 1, 2, and another 1? We cannot. Because inside it has the same number 1, because in this array we have a 1, and in this array we also have a 1. This is not possible. So this is the meaning of the partition. So if we understand about the partitions, basically we need to just simulate some numbers and try to find a pattern. If we can find that pattern, basically the problem is going to be easy. So let's just try to use more examples. So according to this example 1, 2, 3, 4, so it is okay. We can have different kind of partitions. So there are 8 combinations. So like we can have 1, 2, 3, 4, or 1, 2, 3, and 4, or 1, 2, 3, and 4. As we can see, there are a lot of different kind of partitions. But let's just try to use another example, maybe the second example. If we have examples of 1, 1, 1, 1, so how many partitions? We can only have 1 partition. It's going to be 1, 1, 1, 1, because we can never make it to 2 partitions, like 1, 1, and another one will be 1, 1. Because there will be duplicate, because in this partition and in this partition there's a duplicate of 1, so that is not possible. Let's just try to find other cases. So for example, if we have a number 1, so we want to find a partition, so from the right side, so let's go from the right side. What if there is another one, and after some time there's another one? So will this 3, 1, maybe in between there will be other numbers, it doesn't matter. So will this 3, 1 be inside one partition, inside one subarray, or it will be inside 2 subarray? Of course it will be inside one subarray, because if you put it inside 2 subarrays, definitely there's a duplicate of 1, because here we have 1, 2, 1, here we have another 1. Definitely we have the duplicate of 1, because that is not possible. So it is, if it is like this kind of case, definitely we cannot make the subarray smaller. This is the smallest subarray. Now let's just continue to check. So what if from here we have another number 2? What are going to be the partitions? So here we have a number 2. It is okay. So we can make the partitions like from here. But what if there's another one? Of course we will put it inside one subarray. So this is just the pattern. We need to find some patterns like that. Maybe at the right side there's another 2. So what is it going to be? So this is a 1, 1, it comes to here, and another it will be 2 and 2. So the whole part will be a subarray of partition. We cannot split it anymore. Because this is like 1, 1, it comes to here, but this 2 is just in between the 1, 1. So it means we have to extend it, and all those will become the whole subarray, and this will be the smallest subarray. So if we can find this kind of a pattern, basically we can solve the problem. So let me just use another example. Maybe we have 1, 2, 1, 2. So definitely this will be a partition. Now we have some other numbers, maybe 3. So 3, definitely it will be the smallest subarray. Maybe there's another number 4 or another number 5. So how many partitions? So first of all, we're going to find the smallest, the maximum partition which we can have. So how many of them? 1, 2, 3, 4. So if we have 4 of them, definitely we can calculate how many of them. Because for each of the for each of the time, we can choose to have like this one with 3, or this one with 3 and 4, or this one with 3, 4, and 5. Yeah, definitely we can choose all different kind of combinations. Yeah, so for this one, for the first one, we can choose it or not choose it. So how many of them? It will be 2 to the power of 1. And for the second one, this one is also, we can choose it or not choose it. So it's going to be 2 to the power of 2. If we have another one, it is 4. It's going to be 2 to the power of 3. If we have another 5, so how many different kind of combinations? So yeah, it will be yeah, let me just think about it. Yeah, if the length is 4, definitely it is going to be 2 to the power of 3. It's going to be 8. So this is 4. I think it's going to be 2 to the power of 3. Yeah, it will be 2 to the power of 3, because for each one of them it will be 4, and we can, how many 2s? We can choose this 2. Yeah, we can split it from here, or from here, or from here. Yeah, so for each of the time, we have definitely we have 2 choice. Yeah, so let's just check this kind of bars. So how many of these kind of bars? There will be 3. So for the bars, we can put it inside or we can leave it out. So how many different combinations? So for this one, it will be 2. And for this one, we can put it inside and we can leave it out. And there will be another 2. So it will be 2 to the power of 2. And for this one, similarly, we can put it here or we can leave it out. So yeah, we just need to use this kind of insert plate idea to solve the problem. So it's going to be 2 to the power of 3. And similarly for this one, there are 4 numbers. It will be separated. Yeah, 2, 3. We can insert 3 bars. We can put it inside or we can leave it out. Yeah, so it will be 2 to the power of 3. It will be 8. Yeah. So this is going to be the idea to solve the problem. We just need to check how many plates we can insert in between all of them. Yeah, so this is the smallest unit, and this also going to be the smallest group, and we just need to find how many plates we can insert in between all of them. Yeah, now let's just try to use this idea to solve the problem. Basically, this is going to be a merge interval idea. Yeah, because for example, this is 1, 2, 1, 2. So for those 2 ones, we can find a length. For those 2 2s, we can find a length. Basically, we're going to merge them together. So it's going to be the merge interval idea. And we just need to check how many unique such kind of a group. So let me just use a dictionary to check all the merge interval places for each of the number. So it's going to be yeah, let me think about it. Yeah, let me just put a integer. Yeah, or it should be a list. Yeah, let me just put a list. Now I want to check all the numbers, so I'm gonna enumerate the index and the numbers. So for in enumerate all the numbers. So I want to check if this number is inside my dictionary. So my D zero. I want to use this number, D N. This number with 1. Yeah, because if it is inside, I just need to check the right side. Yeah, so it's going to be updated to I. Otherwise, so this dn should be equal to left and right side should also be the same. It's going to be this index I and I. Yeah, so this is idea is just like that. We just need to find the index. For example, this is the index 0, this is the index 2, and this is 1, 3. We just need to merge 0 to 2, 1 to 3 together. So it's going to be 0 to 3. So this is going to be one group. Yeah, I think this one should be okay. Now let me just check what is inside the dictionary. Let me just return 0. Yeah, so this is exactly what we are checking. So for this number 1, the left and right side should be 0, 0. For 2, it's going to be 1, 1. 3, it's going to be 2, 2. And 4, going to be 3, 3. And let's just check another example, maybe example 2. So for this number 1, it's going to be from 0 to 3, because those 4 ones will be inside one group, and it's going to starting from index 0 and adds from index 3. So this is exactly what we need. And let's just check this one. So the last one. So for 1, it's going to be 0 to 2. For 2, it's going to be it's going to be 1, 1. It doesn't matter because 2 is just inside. And for 3, it's going to be 3 and 3. So how many? After that, we're going to merge intervals. So after merge, so this 0, 2 and 1, 1 going to be together. It's going to be one group. And this 3 going to be another group. Yeah. So this is just the idea. So now we finished the first step. Because our result going to be modular, the mod. So I'm going to prepare a mod. It's going to be 10 to the power of 9 plus 7. Now we are going to merge the intervals. Let me prepare a result. It's going to be called how many intervals do we have after merge. Let me prepare a right position, because at least we're going to have because the num's length is at least 1. So let's just prepare the array first. So let me prepare an array. It's going to be the sorted of d dot values. Yeah, so this is the d dot value, so we just merge the intervals. Now, I think we can just merge it. So let me just prepare the first position of the right side of the first interval. So it's going to be a 0, 1 with 1. Yeah. Now let's just check from the second interval. So for left and right in A1, and let's just check the left side. If the current left is more than the previous right, so this means we need to update the result. So our intervals will code by 1, so it will be increased by 1. After that, we're going to update the right side, so it's going to be the maximum of the right, previous right with the current right. And finally, we just need to return a power 2 to the power of the result with the mod, because our final value would be mod this value. As I explained, we just need to check how many insertions. So for this example, so for I didn't, maybe 3 and 4 and 5, and for this example, definitely we have 1, 2, 3 insertions. We have 3 board. We can put it inside, or we can leave it out. Yeah. And similarly for here, this is just used to check how many intervals. So for this result, it is the intervals, the final intervals, the total number going to be result plus 1, because after the for loop, there will be the last interval for the merge interval algorithm. If you know about this kind of greedy algorithm to calculate how many intervals, so finally we need to use the result plus equal to 1. Yeah, but for our final result, we don't need 2 plus 1. Actually, it will be 2 to the power of result minus 1. So here is the result plus 1. So here should be the result minus 1. So we don't need to use this line, yeah, according to our calculation, because we are not counting how many intervals. We are just counting how many boards. So the number of boards is going to be the number of intervals minus 1. So this is exactly here. Yeah, where's my code? Yeah, it's going to be exactly here. Actually, here is a minus 1, because here plus 1 minus 1, so it's going to be the same as result. Yeah, so this is going to be the entire code. Let me just run it to check. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works and it's pretty fast. And the time complexity is n log n, because here we used a sorting, so this sorting gonna be n log n time. Yeah, so this n is dependent on how many intervals do we have. So just imagine, maybe the worst case it's like 1, 2, 3, 4. So the total number of intervals is going to be the length of the nums. So the length of nums is 10 to the power 5. So this is going to be the n. The final time complexity is going to be n log n. Yeah, and this idea is very, yeah, it's not so difficult to think about it, but we must make some drawings to check how many groups do we have. After counting the groups, basically we can use insert the board idea. In mathematics, it's like combinations. How many different combinations do we have? We can just use the insert the board idea to check how many insertions of the board we can insert. So for this example, it is 1. For this example, it is 3. And the final result is going to be 2 to the power of this number, 2 to the power of 3, or 2 to the power of 1. Yeah. So as you can see, the answer this is 2 to the power of 1, it is 2. This is 2 to the power of 0, it is 1. This is 2 to the power of 3, it is 8. As you can see the result, it must be a value 2 to the power of some value. Yeah. So thank you for watching. See you next time.